Hello, everyone. We've finally returned as JJ Coffee Talk, and as our Christmas special, we're going to talk about quantum finance or quantum markets, as I titled this.
Mm-hmm.
Um, yeah, so what prompted this was this Economist article that we read, and
I did not understand.
yeah, and then she asked that I could look into it and explain it for Christmas, so this is sort of a Christmas present.
Mm-hmm.
And yeah, so it had a very cute, like many Economist articles, it had a very cute cartoon, very clever cartoon where this is like supposed to be Schrodinger's cat.
Oh, I
so,
didn't notice that.
so that's why it's part cat, and then it's also like um, moving up or down.
It's like this from the stock market.
Yeah, so it's like red or green depending on how the stock will perform.
Mm-hmm.
And that's because like Schrodinger's the idea behind this cartoon is that Schrodinger's cat was like um, a sort of a thought experiment for superposition. It kind of showed how yeah the cat could be both alive or dead until you open the box and evaluate
Mm-hmm.
what the state actually was, and that's sort of how um, that's how particles work at the quantum level, where they like you don't know if the like you don't know what state the particles are in until you evaluate them, and then they collapse them, like you actually change its state by observing them. So that is very important. That's a very important idea called superposition.
So, can you observe their state or not?
You can, but it changes their state.
So, you're observing the changed state.
Yeah, you only get the observed state, but they exist in superposition until somehow you observe them and they collapse.
So, you never know what the
Yeah,
state
you never get the
before.
state like in itself.
I see.
To quote Kant, there's like no thing in itself, and and yeah, physicists figured that out. After years of particle and accelerators and everything. But anyways, so yeah, the idea behind this was that yeah, some asset price could be either like going up or down,
Mm-hmm.
and that's sort of like in superposition, just like the cat. It's either alive or dead, and that's sort of the key idea of how quantum computing applies to financial markets because yeah, they can use it to better evaluate the asset price.
Mm.
So yeah, I did some research into how this actually works.
Cool. Let's get started.
Okay, so I want to start with the basics of basically what is quantum computing, like what are quantum computers.
Mm.
Um, so basically, they employ quantum mechanics as the physical basis for computation.
Mm.
So contemporary computers, as like the one we're using now, basically just has um, binary states with transistors. So like transistors actually depend on some quantum behavior, but they uh, just use them to have a very efficient, very small switch, basically. So they use them to create these binary switches that they can compress down to like a tiny chip.
I see.
And like contemporary computers have binary circuits. There's circuits just composed of switches that can change state with an electrical impulse, and then it uses that to perform all these computations like addition, subtraction, any algorithm we want to perform on like the real numbers.
So, quantum mechanics can also be controlled.
Mm-hmm. Yeah, but quantum computers aren't just a binary switch. So this is the key thing.
I see.
Quantum computers don't just have switches. They have uh, through this unit that they call a qubit, like a quantum bit, they can actually store a vector.
Mm.
So it's a linear combination of states, of the particle states. And yeah, that's what's called like a qubit. It's like a linear combination of 0 and 1. This is why
Mm.
you've sometimes heard it like sort of oversimplified as a quantum computer can be any state between 0 or 1.
Oh,
So that's somewhat true, but it exists as a vector. Like
I
it
see.
exists as a linear combination.
Mm.
So this is like I think this is called a block sphere. I'm not super familiar with physics, but I know I took some courses on the mathematics, but
Mm.
um, yeah, I'm not definitely not an expert in all this. But yeah, I actually read most of my material comes from an article I read by a statistician on by a statistician on the applications of quantum computing to
Mm.
statistics. But yeah, basically, like this is like a vector, which is so this like this I think that's psi. This is also Bra-Ket notation, which we don't really need to get into. But this basically, I think this represents that it's a column vector.
Okay.
No, actually, sorry. Yeah, I think this is a column vector. Um, so then, uh, because it's surrounded by these by a ket, so the so this psi is the state of the particle,
Mm.
and basically it's a vector in it's like a unit vector in complex coordinates
Mm.
basically. So it can be any point in the complex plane. Do we need me to explain complex numbers? Or are we good on that?
Yeah, I think I learned that before. So
Okay.
on the plane, by plane you mean this sphere,
Mm-hmm.
sphere.
Yeah, sorry. Yeah, complex space. I should say space, not a
Oh,
plane.
yeah. Okay.
Yeah. So it's like in complex space, and it can actually like the more qubits you have. So
Mm.
this is where it gets like really crazy. The more qubits you have, the more dimensions it adds to the
Mm.
complex space. So like for b qubits, you have 2 to the b
Mm.
dimensions. So it's like it can get like it can have like very very high storage. Um like exponentially high storage the more qubits you're able to maintain. So that's why people got very excited about quantum computers
I see.
and their potential to store like tons of information
Mm.
and use them all in computation.